Um, so before we discuss entity tags, let's discuss about what is concurrency control, what is different types of concurrency controls, what do we use in SAP ABAP, traditionally and all. Okay, so you can see my screen, right?
Yes, we are able to see.
Okay, so let's say when you are sharing a resource between multiple applications, there is a problem of overriding somebody else change, right? So we want to organize these resources in a multi-application environment. We want to maintain that data without corrupt or without bad read and all, right? So if we have been working in application or software industry, we know what the concurrency is. So traditionally in ABAP, if you go to any transaction, most of the times what we do is we log that resource. Even if somebody enters into the transaction and tries to read or update that particular resource, we will just say this is locked by somebody else, so you can only get the read copy, right? So traditionally in ABAP and in SAP we follow this pessimistic concurrency control. What that means is we assume that somebody else will read and update. So whenever we access a resource, we try to lock it. So and we don't release it till our task or application task is completed. Okay. So let's say if you open a CJ20 transaction in project systems, let's say if you open a project, you are going to if you open a project in the edit mode, you are going to log that project for the updates. So nobody else could come into that project in the edit mode until or unless the application or you release that control. Okay, that is called pessimistic concurrency control. The problem with this pessimistic concurrency control is there are lots of applications which wait on the resource that you lock. Let's say when you open a project or some resource in the edit mode, probably you might not doing edit at that point of time, but you just open in the edit mode, so it get an exclusive lock for your application or for your user. Okay, so until or unless you release that project or that resource, everybody is going to wait on you. So this will bring down performance drastically. And let's say while you are waiting on this resource, while you are updating this resource, let's say if the application is waiting on some other resource, then you potentially can create deadlocks in the system, because you hold this resource and you are waiting for some other resource, and on the resource that you hold, some other applications are waiting on your resource. So it can cause a loop of deadlocks, and potentially sometimes could bring the systems down. So that is the problem with the pessimistic concurrency control. In the pessimistic concurrency control, you always assume that somebody else will update the resource that you are working on. So cautiously you are going to lock that resource so that nobody else could update it. Okay. Do you get it?
Yeah.
So the other flavor is optimistic concurrency control. You see this one in most web applications and all. In this optimistic concurrency control, you don't assume that somebody else will update it. There might be a chance that somebody might update it, but you don't assume. So you don't aggressively lock it, so that whenever you are ready to update, or you are ready to update the resource, then you will check whether whether it is updated or not. If it is not updated, then you go ahead and update. but you don't aggressively lock the resource. That is optimistic concurrency control. So in OData, we are going to achieve this concurrency control. We are going to use optimistic concurrency control, and we are going to use entity tags or e-tags to promote this optimistic concurrency control in OData. Okay.
Okay.
So that is the theory part of it. So let's see an example. This example explains what the last update problem is. Let's say if user 1 access a resource or document through HTTP method, HTTP get method, and starts editing it. So after user 1, user 2 also access the same document again through HTTP get method. Now user 1 and user 2 have the same copy of document or resource. Now user 1 saves the edits that he is making to that resource and commits to the database through HTTP put method. Now the user user 2 will also save his edits to the database. In this scenario, you are potentially overwriting user 1 changes, so which creates the last update problem. Okay, user 1 then loses user 1 lost their edits as user 2 overwrites them. Okay, this is the last update problem. So we are going to solve this last update problem, and we will see how concurrency control is implemented in OData through e-tags. Any questions, guys?
No.
So in OData, there are different e-tags. First one is a field-based e-tag. E-tag means entity tag. Okay, field-based e-tag, or the second one is entity-based e-tag. Okay, there is a third flavor of it, but we are not going to use it. It is a partial entity based e-tag. Okay, so let's discuss field based e-tag first, then we will go to entity based e-tag. Okay, so instead of we are working on this enterprise procurement model OData service for the last 1 or 2 weeks. Earlier we have worked on this
Bank.
banks OData service. This has the whole life cycle of this has the whole life cycle methods like create, update, read, and delete. Whereas in our case, in the enterprise procurement model OData service, we are just reading it differently. We are reading through associations and navigation properties. We are expanding and all, but we haven't covered the whole range of create, read, update, delete. So for that reason, I'm going to use this banks OData service that we have already created in the earlier sessions. Okay.
Okay.
So if you look at the bank uh, entity, there are lots of properties. One is the bank key, bank name, street, city, state, country, bank number, branch, routing number, created by, and created it. Let's say in our database table, potentially we are writing all this, whenever we create an entity, we are writing it to BNKA
Comparative.
BNKA table, right? So here, we have properties for who created it, when it was created. So let's assume that, in the same database table, we maintain who changed it and at what time it has been changed. Okay. So there will be, I mean, two properties called, there will be two on bank entity. On bank entity, let's assume that we have two more properties. One, changed at, two, changed by, right? So let's assume that this changed by is a timestamp when that record is changed. Okay?
Changed by will be a timestamp, or changed at will be a timestamp?
Changed at. So changed at, I mean, let's say whenever I mean some application is writing to BNK a table, it records the time also. Okay?
Mm-hmm.
I mean, since we don't have it, we are just I mean talking in hypothetical sense, but let's just, so I mean let's just take this ER date as changed by, just for, I mean, hypothetical sense. Okay, it is not I mean it is just that. So I come here and on the entity I will choose, I mean if you see on the entity there is a property called eTag. Okay, what I will do is I will select the changed at, I mean property as my entity tag, right? So every time when I mean let's say when I read the data, right? Let's say when I read uh, the bank information, then I will get, I mean when that record was changed, right? Do you understand?
Yeah.
So I mean whenever we read the bank, the bank eTag information will contain last changed time, right? Let's say we read this bank and we are trying to update it. So before we update, we read this bank again in our OData service. The framework, I mean, whenever you maintain this E tag, the framework automatically read that E tag, I mean, in this case, the last change time. If it is, I mean, the same time that you are providing and it is the same time in the database, then only it updates. Otherwise, it will send you an error message saying that, I mean, somebody else has already updated your record. So try to get a fresh copy and I mean update it. Okay.
Mm-hmm.
So but the problem with this field based ETag is, I mean, most of the times your entity might not be coming from just one table. Probably it might come from several different tables. Then the field based ETag might not work. Or let's say in the database table, in BNK table, we have only taken a subset of, from BNK table, we have only taken a subset of properties as the entity, right?
Mm-hmm.
But there are lots of other properties which can be changed by some other processes which could potentially change the change date timestamp, right? Then you are
Yeah.
not going to get, I mean, correct concurrency control and all. You understand?
Yeah.
So the field-based e-tag, I mean, might not be, I mean, uh, might not be a proper. I mean, probably it might work in some scenarios, but it might not work in every scenario. That's why we should go for the entity-based e-tags. So let me show you what the entity-based e-tag means. Okay, so there is a function module called, okay, there is a function module called calculate hash for raw. Okay, calculate hash for raw. Let's say if you give some information to this, I mean, it accepts data in the, it accepts your data in the X string format, and I mean, we are going to take the I mean, default algorithm SHA1. Okay, so let's say I enter 1 2 3 4 5 6. So I will get a hash value based on the data that I have passed, right? So this is the hash. So even if second time, if you pass the same information, the hash value is going to be same. Let's say if I run it again, so the generated hash value will be same for the same information. Let's say if some of the information is changed, then it will give you different hash value, right? So for that reason, we will use, I mean, this hash value as a e tag, right? So if you look at it, the data type is hash 160. So let's go, and so this is our structure. This is our structure with which we have created bank entity. So let me go ahead and create a field called e tag, okay, which is of type hash 160. Okay, let me update my structure. I have updated my structure. Then I will go to, since I have added a new entity, okay, to this structure, what I will do is I will just going to, okay, let me go back and come back again.
Right click on data model.
I don't think so. Not from here. Actually, you could, I mean, whenever the structure is changed,
Right click on change.
there is nothing called, I mean you actually import it. Okay, let me okay C11 so import
Maybe redefine. No.
no
Change is not enabled. Bank.
let me see. Okay, let me add it here. Let me add the
Yeah.
e tag here, and let me say e tag
Entity tag.
tag. It is not key, and since it is char 40, I am going to say EDM string, which is of type 40. Okay, so I'm going to save it. So
Runtime objects.
what I will do is, on my entity type, I will choose the newly created etag property as etag on this entity.
Yeah.
Oh, sorry, and actually we are embedded. So let's choose etag property as etag on my entity. Okay, so I'm going to save it, and I'm going to generate the runtime artifacts. So if you go to the runtime artifacts, if you go to the modal provider class, we should see what are all the changes that we made. Uh, could you please guys put in on mute? I could hear the background noise. So in define bank, okay, so the new property should reflect here. You will see the property etag, and it is of type string, and when it is of length 40, and it is set as a etag. You see here, right? So we see the property that we have added it during the design time is reflected in the runtime objects. Okay, so what I will do is, while we are creating the entity set, what I will do is initially I will create a method called calculate hash, right? And I will say instance protected or public. So for the entity, okay, in the calculate hash, I will add two parameters. One is CS data type importing, okay, pass by value, it is not optional. I will just say any. You pass me any data, I will change into X string and I will give you the hash value for it, okay. So I'll say hash returning, this is a returning parameter, and pass by value, and it is hash 160. So these are my two parameters. So I will take any data and convert into X string and pass that X string to this calculate hash for raw function module. Whatever the hash that I receive, I will give it back. I will give it back as the e tag value. So I will define data string type X string. Okay, data LV hash type hash 160. Okay, so what I will do is whenever I receive any kind of data, I'm going to CS data to data buffer. I'm going to, this statement will convert any data into X string, okay, LV X string, okay, and once I get the X string, and I'm going to call this function module. So I'm going to call this function module. So I'm going to say algorithm equal to SHA1, data will be LVX string, and I'm not going to read all this data, just hash equal to, get rid of the length, hash equal to LV hash. So let me get rid of this. If LV hash is not initial, hash equal to LV hash. Okay. So what I have done is whatever information I get, I'm going to convert it into X string, and I pass that X string to calculate hash for raw function module, and I'm going to use the algorithm SHA1. Whenever I receive the hash value, I'm going to send it back. So whenever we are getting the bank entities, what happened to this banks info thing? We have implemented this, right? Okay. Let me just copy this. Somehow I lost all my implementation, so I'm just copying it back. Okay. Okay. So banks underscore get entity set. So I'm going to read all the banks, from US and New York. Okay. LUI 5 banks. Okay. But while reading the bank, what we do is we are going to calculate the hash. Okay. What we will say is ls sr bank hyphen etag equal to we are going to call, okay, calculate
Hash.
hash, and we are going to pass this entity, this structure. Okay. So let's execute it and let's see whether we will get. So this is my bank service. So I'm going to call. So let's add metadata and see whether we can see the property. So we can see bank key, bank name, and we can see e tag. Okay, and we will see all those details. Okay, so let me go ahead and call the bank's entity set, and let me add system query parameter format equal to JSON. Sometimes this is weird. So let me just take out this format equal to JSON. So if you look at it, I mean, if you see each entry comes with its own e tag, right? I mean, this is like GUID. I mean, you can't. I mean, it is not for us to understand what it is contained. It is just random 40 characters, or I mean, some characters. I mean, bunch of characters which we are not. I mean, meant to understand. But let's say each bank comes with its own e tag. If you see, so let me call it from. So if you see for each individual bank or for each entity, you will see the e tag in the metadata. Okay, this is your e tag. So this e tag is based on this information that is contained in this bank. If you see here, you will see the e tag. Okay, similarly, I mean, you will see the e tag for this bank. So let's implement the same thing in the get entity too. You understand up to this point, right? Okay, so we will do the same thing in the get entity too. This is for create, I guess. It is messed up here. So what I will do is, the less entity type ZLUI5 banks. Okay, data ls key tab type. Okay, read table IT key tab into ls key tab with key name equal to bank key. If ls key tab is not initial, and if, okay, select star from single star from bnka into ls bnka, where bank L equal to ls key tab hyphen value. Okay, so once we get the ls bank A, move corresponding ls bnka to ls entity. Okay, and in the ls entity we have a property called etag, where we are going to call calculate hash, and we are going to pass this ls entity. So the etag property is not part of the data which on which the hash is calculated. Okay, and move ls entity to er entity. Okay, so let me calculate hash. Okay, so let me read one particular bank. Whenever you are updating a bank, or whenever you are updating whenever you are deleting a bank, first you read it, right? So for this, I'm just going to say format equal to JSON. So you will get this value. Okay, this is your whole hash value, but this is your whole hash value. Of it we have certain escape characters. Okay, let me read it from here. So, format equal to JSON. Then we will get the e tag value here. This is the e tag value of which there are certain sequence characters we should remove. So this is the escape sequence character. Whenever you are using apostrophe, you are saying with the escape character, so remove this one. So the total hash will be like this. This is your e tag value. Okay. You understand it, guys?
Yeah.
So this is your e tag value for this bank information. So you are going to use this e tag value whenever you are trying to update or whenever you are trying to delete this bank. Okay. So let me implement the other two methods too. Let me update it. The LU Wi-Fi banks. Okay. So what I will do is, let's try to update this one. So okay, let me put this delete too. Okay. So whenever we are trying to update with entity tags, there are a couple of things that we need to take into consideration. Okay. What that is let's say you got the E tag, and there are a couple of HTTP request headers. You got to take into consideration. The one is if match, and the other one is if none match. Let's say, when you first you read an entity, then you will get the E tag. Then while you are trying to update it, you pass the HTTP request header if match equal to the E tag. What the framework does is, again, before it updates that bank or entity, it calculates the E tag. If the E tag that you provides and the E tag that framework calculates matches, then it will update. Otherwise, it would not. Okay. So I'm going to use the same thing as request. Oh, why this one is displayed like this? Okay, 1 second, guys. I have lots of sessions, so let me just.
You please reload the metadata and try for that service.
Don't know why. Okay, let me request in this format. It gives you properly. Then read a particular bank. Then you will get your E tag. Okay, this is your E tag.
Yeah. Now we are able to see.
Hello? Hello guys?
Now we are, yeah, now we are able to see the screen.
Okay. So we will get the e tag, okay? Use the same thing as a request. Okay, this is little bit. So let me request in the you get the same e tag but use this one as a request. Okay. You will get bank key, bank name, street. So the routing number. Okay. So I'm going to delete the metadata, which I don't need. So in order to test it through, two users, let me get another session too. I will read the same bank. I will read the same bank. So if you look at the e tag properties, you will get the same e tag. So this is session 1 and this is session 2. This is the e tag. If you look at it, it is the same e tag. Both the e tags will be same because we calculated the hash value based on the same properties, right? So you will see the same e tag. So what I will do is, so this is my first one, okay? I'm going to update it. Let me go to my data provider extension class. Let's see so that if it is updated successfully. Okay, so I'll go to the first one and let's change the state to New York and change the country to US. Okay, and let's change the branch information to just deleted some parts, and bank number I will put the same bank number. Okay, so let me update it. So I will delete this format equal to JSON. Okay, and I am going to add a HTTP header called if match. What I am saying is, I mean, if this e tag matches, then only update it. So since it is the same e tag, I'm going to say, okay, so while updating, I have added a HTTP request header called if match equal to the e tag that I received when I read this entity. Okay, so let me execute it. So everything is good. So if you look at it, I mean, it comes to the banks underscore get entity, because when we are trying to update, it will read, I mean, the bank entity again so that it can match the entity tag. So it read the, first it come to the get entity, then it goes to the get update, because we have the same e tag, right? So it goes and it updates. It is size of RC equal to 0, and it updates. I mean, we get the code 204. Okay, you got it, guys? Let me go to the
Yeah.
second one. So let me go to the second session. I use it as the, I mean, request. Okay, let me put it in order. Okay, so instead of, I mean, the bank name, let me just change it to Bank of New York. Even here, I'm going to delete this format equal to JSON, and I'm going to use HTTP method put, and I'm going to add a HTTP. Let me delete the metadata here. I don't want to pass the metadata. Okay, so I'm going to add if match and whatever we have received for the second session, right? Okay, so I use HTTP method put. So I added the e tag, I mean the one that I received when I read this bank information or when I read this entity. Okay, so I changed something. Now, I mean, user 1 read the same bank. After that, the user 2 read this bank. Now user 1 updated, right? Then user 2 is trying to update. Okay, he did not get the fresh copy, but he is trying to update with the entity tag that he received. Let's see what happens. First it goes to get entity so that it can read the E tag. Now the E tag will be different. Why is it different? Because the data is changed. Wow. Are we on the same page? One second, guys.
I have taken the old data only as a request.
What is that? Yeah, that is what we should do. Okay, one second. So let me read the data once again. Okay, this is session 1. Get the data. Function write. Now it says precondition failed. Okay, let me delete this. Now you get the different. Now the first data is okay. One second. Let me do it once again. Okay. Now we have two. We got the same. We got the same. One second. Now session 1. E tag. It is the session 1 E tag. The second one is it is session 2. E tag is the same one, so we received the same E tag. So let me read this. So I'm going to use this data. I'm going to use this data. So now I'm going to delete this metadata. Okay. And now let me delete this E tag. I'm doing it on the first session. Okay. So let me add if match the E tag. This is the E tag. So I have added this E tag, and let me change from Bank of New York to Bank of NY. Okay, street, Lower Manhattan Street. Okay, then city, New York, state, NY, country, US. Okay, I'm going to put the same bank number. Okay, so I'm going to delete this. Okay, so this is session 1. In the session 2, I'm going to copy the same data. I'm going to copy the same data and delete the metadata, and I will keep the same information. Okay, and I will add if match from the second one. I'm going to say put. Okay, even in the first case, so in the second case I'm not going to change it. I'm just going to delete the E tag. Okay, and even in the first case I have changed all of this data. So let's look at it now. So when I got, sorry, so uh, I should have put,
Instead of another put.
yeah, let me put the data once again. So let me delete the metadata and change it again. Okay, let me delete the E tag. Okay, now I'm going to put HTTP I'm going to use HTTP put method. It is the same E tag that I have been using. Okay, let me execute it. Okay, function F6. If you look at the E tag, it is the same E tag because we haven't changed the data. So it is the same E tag, function F6, control F8. Sorry, we got to put okay, let me read it from here. Format equal to JSON. That let me delete all of this. Function F8. Okay, bear with me, for a few more minutes, guys. I'm just going to say format equal to JSON. Okay, let me delete all of this. Somehow the format is messed up today. I don't know why. Okay, get data. We will get the same e tag because we haven't changed anything, so we should have the same e tag. So in the case of first scenario, this is the e tag. In the case of second one, it is the same e tag. Okay. In the first case, let me use it as a request and bank key, bank name, bank street, city, state, country, bank number, date, routing number, created by, created at, e tag. Okay, I'm going to get rid of the e tag. We don't need that. Okay, and let me delete the metadata first. So this is the information that I'm sending. So let me change it. Bank of New York, my downtown, city New York. So state NY, US, social club. Okay. Number. Okay, this is the information that I'm passing. So for the second one, I'm going to use HTTP method put. I'm going to get rid of format equal to JSON. Okay, and I'm going to add HTTP header if match, and the e tag I'm going to pass whatever I have received. Okay, so let's go to the second session. So let's use it as a request. Let's get rid of the metadata. Let's get rid of the metadata. bank key, bank name, city, state, okay. I'm going to get rid of this format equal to JSON, and I'm going to use HTTP method put, and I'm going to use if match header to the second one. Okay, so we are good with go ahead with the first session. Okay, we have done everything, good so far. Let's see. Now we will read, the framework, we are not reading, but the framework reads the entity tag. Let's see the entity tag. So this is the entity tag. So it is same as we have passed. So I think it should go fine. Function F8. Now it come to the update bank underscore update entity. So I think it will update fine. So it will update fine. Okay. So let me go to the second one. Okay. Let me go to the second one, and I put I updated the data and I added the same thing. So let me see what is the entity tag that I receive now. Sorry, I have put wrong data here. I'm reading it. Oh, sorry. No. Okay, function F6. Now it should get a different entity tag. Why is it getting the same entity tag? Bank of New York. Why it is not updated?
Maybe you have to go out of that session so that it commits it or something like that.
No. One second. Sorry. This is a less entity, right? Oh, we have updated it, right? Oh. This is our data. This is Bank of New York. When we are 1 second. So this is my third session. If I read it, why is it getting the same entity? Why is it getting... Okay, let me look at the update table. Update one. So let me call it from the same one. Did and everything good. Okay, function F6. Okay, this is good. Function F6. Let's say if sub RC equal to 0, but let's go to the table BNKA. Let's see the bank key. There are two records, which is messing us. Somehow it has two records. Okay, let me delete the first one. Did you see, guys?
Yeah, we can delete that first record with country codes here.
Yeah, let me delete this one. Okay, let me add. So we deleted the first one. I think it deleted both. So let's try with some other example. I mean, let's just take something which has just one record. Is it getting late for you guys?
Yeah, no problem.
Hey, what about Shibu?
Yeah, it's okay.
I mean, it will take a while. If you think it is okay, I mean, we can continue. Otherwise, we will continue tomorrow.
Yeah, let's do it tomorrow otherwise.
Okay. Yeah.
I mean,
Let's.
I mean, if it is okay for the others, I'm also okay.
And it will take another half an hour. I think. I mean, I'm okay either way. I mean, it's up to you guys.
Yeah, it's okay. Let's do it.
Okay. So let's read it. Okay. Let's delete. This is get. Even this one is get. Let's see. I think this one looks good. This one looks good. Let's see how many records it has. Let's first check how many records exist with this key. Okay, there is only one, so let's go ahead with this one then. So let me read it. Okay, so this is session 1 and this is session 2. Okay, so let's take the e tag of the first session. Okay, this is the e tag, and even in the second case we should have the same e tag because okay, it will have the same e tag. Okay, so let me change in the first session, use it as a request. I think there is something wrong with it. And if you see the data here, it is perfect. If you see the data here, if you see the bank name here, somehow the spaces are gone. look at this table, this is the data. Okay, let's let's delete the E tag. Okay, it is Chase Manhattan Bank. This is Park Avenue. This is New York. Okay, so I will use HTTP method put. I will add if match request header. I will add if match request header equal to E tag that we received. Okay, let's just add branch saying that Manhattan branch. Okay, routing number, let's say 9999. Okay, so this is the first session. I have added if match header to entity tag that we received. I put HTTP put. So in the second session, what I will do is I will use it as a request. I'll use HTTP method put. I'll take this format equal to JSON. Okay, I will take this metadata out. Bank key, street, 270 Park Avenue, state as city as New York, state as NY, country as US, bank number same, branch as instead of branch by created it. So instead of Manhattan branch, I will say Park Avenue branch. Instead of routing number, I'll just say 888. Okay. I will add HTTP header if match second, it is the same value. Okay. So I use HTTP method. Here we are good. I have added if match request header. Okay. Think the first one looks good. Okay, even it says Manhattan branch. Okay, so let's go ahead and do it. This is the first session. Okay, now we get the same E tag because nothing has changed. We get the same E tag. Nothing has changed, so let's out of here. Say so this is LS Bank. Let's see whether we have received the information that we have passed. We got Manhattan branch and this 9999. Okay, we are good. So let's see this information. Okay, so if we look at Manhattan branch and the routing number 999, we got it here. Okay, so let's go to the second one, and we are good here. We have added the same e tag that we received. Let's go ahead and update it. Okay, let's see. Let's see the e tag here. We should get a new u tag. See, now we get a new e tag. This is the e tag the framework received. Now it is different because the data is changed. Okay, now it should this is the error it should give us. Precondition failed 412 because the e tag that we passed is different from the framework generated e tag because the data has changed. Okay, so every time before we update, what we should do is we should up to this you understand, right,
Yeah.
Shibu?
Yeah, yes.
Okay, so earlier it seems we have two records. It is whenever it is generating the e tag, it is taking the first one into consideration. So it is just keep on giving us the same e tag. Okay,
Yeah.
so before we make any change, what we should do is from the application we should add a HTTP header if none
Match.
match, and we will give whatever the entity tag that we received, okay, and use HTTP get method. Before we update from our side, we will check whether the data is updated or not. If data is updated, it will give us the new UE tag. Okay, then we can use that E tag in the second session when we use if none match equal to before we change before we make any update, we should read the entity again with if none match equal to the entity tag that we received. Okay, then what will happen is if the data is changed, we will get the data again with the updated data, and it will give us the new entity tag. Okay, but let's say if we read it again, since we have this new e tag, let's say if we read with this, so this is the e tag that we received when we request with if none match equal to e tag. Okay, if we read it again with the new e tag before we change it, it says it don't give you anything because it is not changed. Then you are ready, or you are good for update. Okay, did you get it, guys, or is it confusing?
Yeah, got it.
So let me show you what happens in this case of e tag. So this is the flow chart. This is the flow chart. Okay, so we start here, we get the entity set, and let's say, I mean, in this entity set we get all the entities with E tags, but whenever we select a record, we will get that particular entity, and that particular entity will come with an E tag. Let's say when we are, in the application, if user presses the change button after updating this entity, then we will check, we will read the entity again with header if none match, and we will pass the E tag that we received. Okay, then if the data is not changed, then we will submit the update. But let's say if the return status is 200 and the data changed, then we will get the new information with the latest E tag. Then we will show it to the user, and user will change it again and press the change button again. Once we submit the data for update, if the if that entity tag is good, then we will update it, otherwise we will fail it. Is it clear, guys? Do you want me to
Yeah.
go through once again? So anytime, anytime if we want to update it, first we will read that entity, then we will get an entity tag. So before update, we will read that entity again with the E tag that we received. Okay, if the data is changed, then we will get the new data with new E tag. But let's say if the data is not changed, then you can submit that for update. But let's say if the data is changed, you will get the new data and new E tag. Then you will present that new data to the user, so that if user changes it, then you will go through the same cycle again. Before you update, you will check with if none match header equal to the E tag that you received in the read, then you try to submit it. If the data is not changed, then it goes for the update. At the update, in between anything can be changed, right? While doing the update, the framework will check if the entity tag is changed. If it is not changed, it updates. If it is changed, it gives the 412 precondition required error. Then you got to start the loop again. So understand, guys?
Yes.
Yeah.
Any questions?
No.
Even the, we have discussed entity tag, right? We have discussed there are two methods. One is the field based entity tag and the other one is entity based E tag, right? So we have discussed entity based E tag. Even in the case of field based E tag, we are going to give, the timestamp on the changed one, changed at timestamp. Based on it, we will do the same thing. Since it is, this entity based tag is, we use it so much, that's why I discussed this one. Even the field based E tag is same one, same thing, but instead of calculating the hash, we are returning, when it is changed, the timestamp when it was changed as a E tag, but the process is same. Okay. Any questions, guys?
No. What is the partial entity based tag?
The partial
Cancel.
is, let's say, now when we read it, right?
Yeah.
Now when we read it, right? When we read the entity set, we are giving these entity tags, right? But mean, if I wanted to update a particular bank, then also I am reading mean that entity, then I am going to get the same entity tag,
Okay.
right?
Yeah.
Before I make update, I will read it anyhow. So
Yeah.
what this means is, let's say in the entity set, instead of calculating hash on each all the properties,
Yeah.
so if you go to get entity set, right? I mean, instead of passing this whole LSSR bank, I mean, we can just take into consideration only few properties, because in the entity set, I mean, if we wanted to update an entity, we are reading that entity again. But in entity set, instead of calculating hash on all the properties, we are going to calculate hash on some 2 or 3 properties so that it can be done fast.
Okay. Okay.
So that is the partial entity based e-tags.
Yeah. Got it.
Everybody good, guys?
Yes.
So if you don't have any questions, I'm going to wrap up this session for today.